Next, the chemistry and kinetics of the direct oxidation process. Formally, the direct oxidation process is expressed as the CH2 double bond CH2 plus O2 in presence of silver Ag. It gives the CH2 CH2O. However, significant yield of carbon dioxide and water is observed in practice, which can be explained by the complete oxidation of ethylene or ethylene oxide. The reaction is CH2 double bond CH2 plus 3O2. It gives 2CO2 plus 2H2O. Whereas with ethylene oxide, the CH2 double bond, CH2 CH2O plus 5O2, it gives 4CO2 plus 4H2O. The process of heterogeneous catalytic oxidation of ethylene was studied by P.A. Kilte and W.M.H. Scheifler, who suggested the mechanism O2 plus 4Ag, it gives 4Ag ion plus 2O minus 2. O2 plus Ag, it gives Ag plus O2 minus. Now O2 minus plus CH2 double bond CH2, it gives CH2 CH2O plus O. Now 6 O's plus CH2 double bond CH2, it gives 2 CO2 plus 2 H2O. Here the O's refers to the particle absorbed on the catalytic surface and adjacent to the particles of silver. Which are directly adjacent to the oxygen atoms. Thus, the overall reaction is expressed as, the reaction is CH2 double bond CH2, 7 CH2 double bond CH2 plus 6 O2, it gives 6 CH2 CH2O plus 2 CO2 plus 2 H2O. The maximum degree of conversion of ethylene to ethylene oxide is 85.7%. The catalyst for the reaction is metallic silver deposited on various matrices including pumice, silica gel, various silicates and aluminosilicates, alumina and silicon carbide and some more that activated by certain additives, antimony, bismuth, barium peroxide, etc. The process temperature was optimized as 280 degree centigrade temperature. Lower temperature reduces the activity of the catalyst and higher temperature promotes the complete oxidation of ethylene, thereby reducing the yield of ethylene oxide. Elevated pressure of 1 to 3 millipascal increases the productivity of the catalyst and facilitates absorption of ethylene oxide from the reacting gases. Whereas oxidation by air is still being used, oxygen which is less than 95%, which is greater than 95% purity, is preferred for several reasons, such as higher molar yield of ethylene oxide, which is 75 to 82% for oxygen versus 63 to 75% for air. High reaction rates and no need of separating nitrogen in the reaction process, in the reaction products. Now the physical properties. Ethylene oxide is a colorless gas at 25 degree centigrade temperature and is a mobile liquid at 0 degree centigrade. Viscosity of liquid is the methylene oxide at 0 degree centigrade is viscosity of ethylene oxide at 0 degree centigrade is about 5.5 times lower than that of water. It has a characteristic sweet odor of ether when its concentration in air exceeds 500 ppm. Ethylene oxide is readily soluble in water, ethanol, diethyl ether and many other organic compounds or organic solvents.